Well, good afternoon. We're back in the workshop again with some more, avionic related stuff. Some small Lancaster stuff going on. I've had another, the stuff I was testing during the last videos, that's gone back now. That was collected last week. And I've had a delivery of fuel pressure switches, and a dead weight tester has turned up. So we're going to have a good look at that. We're going to have a poke around that. There's going to be a video about that. But first, before we look at the dead weight tester, we need to talk about Bourdon gauges. Yeah, Bourdon, excuse me, once again, I have a script. No expense spared, eh? Spelled Bourdon gauge. Okay. Now this dates back to 1849. These gauges are still in use today. You'll see them all over the place. You possibly didn't realise what they were. Designed by a Frenchman called Eugene Bourdon, and he patented it due to the fact that it was more linear, sensitive and accurate, and it was widely accepted, and it's all over the place. You'll see these everywhere, and you possibly never knew they were called Bourdon gauges. 1852, Edward Ashcroft bought the US patent of Bourdon's design and became a well-known gauge manufacturer. When Bourdon's patents expired in 1875, Bernhard Schaefer of Magdeburg, Germany, began to manufacture Bourdon Tube gauges via his company, Schaefer and Bundenberg. Now, Bundenberg, I think, is still going. Okay, so basically, a Bourdon gauge is a tube with closed ends and thin walls connected to a fixed pipe at the hollow end. All right, so what you have a thin, and it's not, let me just get another picture. Okay, I'll put these up on the screen so that you can see them. So basically, you got something like this. Okay, so this is the one we're looking at here, this type. So you've got a tube, and it's not circular, it's oval. Right, it's been important, but it's oval. It's flat on two sides, basically. And that's closed off at one end and pressurized at the other. And as you pressurize it, this wants to straighten. Yeah. Now, it can be just, if you like, in a C like this, it can be a spiral, it can be a twist, or a helix. Yeah. They all look more or less the same. If you put pressure in them, they want to twist or they want to uncurl, and you can use them for vacuums as well, and they will work the other way, and they will want to curl. So this is going to be a short video, by the way. It's not very long, is it? Right, so what we've got here is, here's the Bourdon tube, this here, the C section. Okay, that's the pressurized end, so that's the open end. You feed the pressure in there, and this will then want to straighten out, so this will want to uncurl. That's connected to this pivot arm by a link. Okay, you've got a rack and a pinion assembly here, and on the pinion you've got the pointer. Yeah. So as this moves, that's going to pull that end, this is going to swivel round, that's going to run that, and the needle is going to move round. And as if by magic, here's one I had earlier. Okay, so you've got that. So as that straightens, that pulls, and that, easy, isn't it? Easy, lovely, simple mechanical system. Once again, lovely analog system, more or less bulletproof. And this is the kind of gauge we're talking about. Yeah, this is my 0 to 30 psi pressure gauge for use with the fuel pressure switches down there. Okay, so it's very simple inside. Pressure comes in, it wants to straighten out the little pipe, yeah, and the mechanical linkage turns the needle. We'll see this in operation when we look at the dead weight tester. So you find these all over the place. If you have a dial gauge, pressure gauge like this, any dial pressure gauge like this, is a Bourdon gauge, all over the place. This one is Like I say, this is 0 to 30 psi or 0 to 2 bar. Call it what you will. They are, put that down there, they're fairly accurate. Modern digital gauges now is more accurate, but they use a different form of pressure sensing system. They don't use Bourdon gauges. The only downside of the Bourdon gauge is because it's a mechanical system, it tends to suffer under vibration. So you get a lot of vibration and the needle tends to jiggle. So what we have, I don't know whether you can see it. I've just dropped something on the floor. I don't know whether you can see it on this one. You see a bubble in there. Okay, so this is actually filled with silicon fluid. Okay, so the silicon in there will damp down any tendency for this needle to vibrate. So on the Lancaster, gauges like that are the oil pressure gauges. Also, the hydraulic gauge is the same, but it works at a higher pressure, and the air brakes for the wheels, because the main wheels are worked on the compressed air system, and the gauge is, it's a Bourdon gauge. Very simple, very straightforward. Hang on.